Welcome to the Industrial Talk Podcast with Scott McKenzie. Scott is a passionate industry professional dedicated to transferring cutting-edge, industry-focused innovations and trends while highlighting the men and women who keep the world moving. So put on your hard hat, grab your work boots, and let's go.
All right, once again, thank you very much for joining Industrial Talk, a platform dedicated to you, industrial professionals all around the world. You are bold, you are brave, you dare greatly, you collaborate, you solve problems, and you're making the world a better place. Thank you very much for what you do, and thank you for your continued support. Now, Samson is in the hot seat. Fictiv is the company, and we're going to be talking about CNC Machining Complex Components. Let's get a-crackin'. Yeah, this is a paper and pencil conversation. You will get right off the bat Samson's passion to help you succeed. Right there. He's amazing, and it's an enjoyable conversation. And Fictiv, I believe Fictiv is really disrupting the way we look and design parts because they're able to provide their platform at Fictiv.com. That's FICTIV.com. And go out there and just look around. But the best part about it is if you say, hey, give me a 10% discount on my first order. Click on it, enter Industrial Talk, boom, 10% discount right then and there. All right, we have no time to waste. Here is Samson. Enjoy the conversation. Samson, welcome to Industrial Talk. Thank you very much for finding time in your busy schedule. Really appreciate you sharing your insights and wisdom with the best listenerships, can I say that? In the universe. Industrial Talk. Thank you, man. How are you doing?
Pretty good, and thank you so much, Scott, for having me on your podcast today. Really appreciate it.
I am so excited. I got to tell you, your form, I'm looking at your form that you filled out because listeners, I don't create this stuff out of it. It's all about the individual being interviewed and what they want to talk about, and I'm excited about this one. Before we get into that conversation there, Samson, give us a little background for the listeners to know who you are.
Yes, my name is Samson Olanrewaju. My last name I know is difficult to pronounce, so you could just call me Samson.
There we are. But I'm going to have your full name out on Industrial Talk.
Oh, thank you. Thank you. Appreciate it. I can have some people practice pronouncing it. But
yes, I am.
Yes. My background is in aerospace engineering. I studied aerospace engineering in Ukraine. I worked as an aircraft design engineer for almost a decade. And I transitioned into my new role here at Fictiv as a technical applications engineer. So I managed the technical requirements gathering for the manufacturing of products, especially for the CNC manufacturing processes. And I support our customers to ensure that all the products we do manufacture meets their quality requirements. So that's the role I play right now at Fictiv.
But you don't just stay within the aerospace. You're able to sort of take the knowledge that you have, the precision knowledge that you have, and be able to apply it to pretty much anything that comes across your desk, right? Correct.
That's the beauty about manufacturing. The fundamentals of manufacturing applies to virtually all industries, right? So currently at Fictiv, as most people know, is not an aerospace company, but we also serve the aerospace industry. So I apply my knowledge not just to the aerospace industry, but as well to the automotive, to transportation, all across board for engineering industries in general. Correct.
For the listeners, please just sort of generally speaking, help us understand Fictiv.
Fictiv, we like to call it the Airbnb of manufacturing industries, or the Uber of manufacturing industry. We have a network of manufacturing partners, and we're sort of the middleman. We manage the manufacturing process for our customer. We take the burden off of their shoulders. So just to explain it in layman's terms, the customers would come to us with their design. We accept those designs, review them, ensure that we can meet those quality requirements, and then we send that to one of our manufacturing partners to make those to manufacture the part. We offer different manufacturing processes: CNC, 3D printing, injection molding, sheet metal, urethane casting, you name it. And we have over 250 manufacturing partners across the globe. This saves our customers so much time from the supply chain issues of trying to find a manufacturing partner, trying to meet the quality requirement. Fictiv manages all of that. And the good thing about it is the customer does not even have to have any communication whatsoever with our manufacturing partners. We manage all of that from the beginning of the manufacturing process to the end of it, even to meeting the quality requirements.
See, I like that. I think that is a great service, a solution that I can't poke holes in it. Are you seeing an increase in additive manufacturing for your process?
Correct, exactly. Most customers are beginning, most OEM companies are beginning to utilize the 3D printing manufacturing process, especially for injection molding. So think about injection molding, right? You have to get a tool in place, thousands of dollars going into creating the tools. You don't want to spend thousands of dollars in creating a tool for a part that doesn't end up meeting your design intent. So we see lots of manufacturing engineers, lots of designers going through the 3D printing process first to get those prototypes in place, test it out, give it a try before then transition into a more permanent manufacturing process.
Brilliant, because that was when back before 3D printing, that was always sort of like, you better get that design, you better get that injection mold spot on. Don't make any mistakes. And it's like the risks were through the roof.
Yeah, exactly.
I like that. That's brilliant.
Yeah, that's genius right there.
It is. It's genius. All right, let's talk a little bit about CNC machining complex components. One, what does that mean? Give me an idea of a complex component, and then sort of state that problem statement. What are we dealing with? Okay, talk to us.
Okay, I think overview first, let's understand what CNC is, right? So CNC is a subtractive manufacturing process. And I like to explain things in layman's terms so everyone can understand, right?
Amen.
So technically you're taking a tool and then you're just machining out or removing material from that existing stock material until it creates the part you want, right? It's an advanced method of manufacturing, but keep in mind with everything, there's always exceptions, there's always difficulties, there's always challenges and limitations. The CNC manufacturing process has limitations because, of course, there are different types of CNC machines. There's 3-axis, 5-axis, and so on.
Just FYI, I went to IMTS up in Chicago. CNC is off the charts interesting. It's Go ahead. Sorry.
It's amazing. It is amazing.
It is amazing. I just watch and stare at it. It's like
sometimes I just go on YouTube and just watch videos of like them just machining.
That's all I do.
Yeah.
It's like when you go to a campfire and you're just sort of staring at the fire.
Yeah, exactly.
You're just staring at this thing spinning around. And
go, it's like, how is that happening? Yeah, that's impressive. So we would consider any manufacturing of component via CNC a complex part if it makes it challenging to manufacture it from the CNC manufacturing process, right? So just an example, CNC has limitations. For example, there is a bounding box or bed size. There are tolerance limitations. Of course, new CNC machines are being manufactured nowadays that can meet really tight tolerances. But then things like tolerances or features on that component that makes it difficult for the CNC tool to machine easily or to makes that part complex. And then in that scenario, as the designer and the manufacturer, you have to start thinking about either alternative methods of manufacturing that particular part or alternative methods of designing that part. So you could go two ways. You could either go ahead and simplify your design so the manufacturer can make it through CNC, or you could all along just change the whole manufacturing process itself.
I have to interject here. What did we do? I mean, the sophistication of today's capabilities, these CNC capabilities, I just can't imagine there's something that is like, I can't do it. I mean, they're just constantly coming out with more. How did we sort of operate in the past when we're tight tolerances? We just couldn't do it.
That's a great question. CNC has been around for decades now.
Yeah.
Right? And the thing about technology is there's continuous improvement, right? There are tight tolerances that before CNC came out, it was impossible to hit.
Yeah.
Like 2/10,000ths of an inch, for example, it was impossible. So things like that, what the designer would do is you would have to kind of like play around with what you have in hand, right? If you don't have a process to make it, then you have to make a lot of tweaks to your design, sacrifice as much as you can in order to bring that design into reality, right? And here's the funny thing. From the designing background, working as an engineer, right, for almost a decade now, it kind of like has a way it plays on your mind, so to say. It's like you as a designer, you already have an idea what's available out there, right, to make your part. So from the beginning stage, from the conceptual stage, you're already designing with the intent that I know there isn't a tool out there that can make this. So I'm not going to bother going in that direction. But now as those tools begin to come into place, as those complex high technology come into place, now the designer is more aware that, I could actually stretch the band to an extent, right? I could now go in that direction. So it changes the industry in general.
And the reliability of manufactured parts increase because of the tight tolerances. There's just so much benefit from all of that.
Yeah.
So with that saying, so we've got, I'm looking at it. Give us some of the problems that we are dealing with today.
Yeah, that's a good question. There are so many things or so many reasons why a part could become considered complex, but because of time, we'll just talk about a few of them.
Yeah.
One of which is thin walls, and I'll just put it as simple as that, thin walls. So thin walls is, imagine you have a component you're trying to manufacture, right? And then some feature in that component has a thin wall. Typically, we would consider something maybe less than 0.5 millimeters for metals or less than 1 millimeters for plastics thin. Those can be challenging, right? Especially for industries that require a lot of thin walls, like in the aerospace industry or in the robotics industry, where there are a lot of shells and casings. The reason why that is a complex problem is that when the machining tool gets to that thin wall, right, the heat transfer to the thin wall and the vibration of the tool can make that wall warp. Right. And by wall, I mean just that feature on that particular component, such that when you send the part out to, say, its assembly location or for its function, it doesn't function as expected because it doesn't meet the tolerance. The face there has some warpage. And the thing about warpage is it's difficult to control. Right. So that is really challenging. And there are multiple ways you can go about that. Well, the question then comes, should we change the design or should we change the process? Like, how can we get that done? There are some scenarios where you cannot afford to change the thickness of the walls on that particular component. So you have to think about either changing the manufacturing process. For instance, you could change the manufacturing process from just CNC to casting and then CNC. What happens is you can cast the whole part and that feature that has those thin walls and then do a finished machining without having the tool come in contact with that wall, right? The downside to that is, while you can meet the requirements of the thin wall, if you require a particular type of fine surface roughness, then you still have to machine the wall, right? So that again proposes another challenge. It's a solution if you're not concerned about the surface roughness of that part, because casting can get you some level of surface roughness. Sorry, go ahead.
Yeah, just real quick. The need for thin wall, is it just a strive for reducing weight?
It could range from reducing weight to assembly requirements or to the design intent of that particular component. For the aerospace industry, absolutely for reducing weight. For the transportation industry, for example, robotics, it would most likely be when you're bringing two components together and it has to have a kind of snug fit to another component and it has to slide in through. So the reasons could vary depending on the industry. Yeah. And then I would say another way to mitigate that would be to change the method of machining the part. So the way the CNC tool goes is it's subtracting material from the bounding box or the stock material. You can use the radial depth of cut approach or the axial depth of cut approach, the RDOC or ADOC. What that is I wish I had a box with me, but imagine you have a box, right? And at the fine end, at the latter end of the box is where the thin wall is, right? Yeah. What the radial depth of cut approach does in the CNC machining process is, instead of taking the tool and just cutting out the stock material, you gradually step it up to the wall. So you could go by, say, take 50% off of the material, come back, take 20%, come back, take 5%, and then come back, take 1%. What happens is it gives the wall time to cool down a little bit, and the vibration is not instant on that particular wall, right? So that gradual process of going back and forth before hitting the thin wall helps mitigate the tendency of warpage on that wall, right? Another approach is the axial depth of cut. So imagine if the thin wall is in the middle of the part, right?
Okay.
If it wasn't a thin wall, the machinist can say, you know what, I'm just going to go ahead and machine everything on the right side of the stock material and then go ahead and machine everything on the left side, right? But if it's a thin wall, what we recommend is the machinist should go ahead and do an axial depth, of course. So what he does is he sections out the right side, and sections out the left side. And then he goes, cut to a particular depth on the right side, stop, lift it up, go to the left side, cut a little depth, stop, and then keep on interchanging.
Yeah.
What happens is the base part has enough rigidity to hold the wall while he's coming down gradually, as opposed to finishing the whole wall on one side and then switching over to the left side. Does that make sense?
Yeah, oh, yeah, complete sense.
Step down allows the wall in the middle to manage the vibration coming in and also manage the thermal conductivity as it goes into the wall.
Yeah, I like that. I like that a lot. And so you've got all these interesting approaches as I look on your thing. And now we have these, those are some of the solutions. What are some other solutions that you can sort of share with us on some of the problems that you are, like the complexity of geometry, all of that? How do you guys just, I mean, let's say I submit something. I go to Fictiv. I can upload the drawing. I do all that stuff. You guys are to do this, the magic behind the scene, which is doggone cool. No doubt about it. And then you come back and you say, it's great, a little complex, but we could do it this way. And take us through that. How do you evaluate something like that when I'm bent on this, I'm bent on whatever it is?
Yeah, that's why I recommend people to use Fictiv, right? Because when it comes to complexity, and I understand this because I came from the design world and now into the manufacturing world. So I see both sides and I see the challenges both sides are facing, right? For complex geometries, right, it's critical to involve the manufacturing engineer at the initial stage of your design, right? If you can. And that's one of the things Fictiv brings to the platform. It's like, you don't have to finalize your design to its highest level of complexity before thinking about sending out to the machinist, because what happens then is you've spent hours and days trying to design this stuff, and then you send it to the machinist, and the machine says, hey, we don't have the capabilities to make this. Like you've gone over the top with this, right? So having team of engineers in Fictiv lets us help you in that design intent, that design phase where it's like you're still building your design. We can let you know the manufacturing capability is limited with this particular type of tolerance, with this particular type of feature. So you might want to change that. So we provide what we call DFM feedback. So that's design for manufacturability feedback. We provide that both on the platform and with direct conversations. We get on a call with the customer. We explain to them what some of the limitations that CNC has and some of the manufacturing feedbacks they can implement to their design to make sure that the manufacturing process goes smoothly, right?
See, now, what I hear you're saying, you're just saying, okay, I've got a design, and I'm all bent. Let's say it's this thing right here, and I'm just nailing it, and I can't stop working on it and tweaking it some more.
Yeah.
What I hear you saying is that I can get it there. You can get the concept. We can and then be able to submit it, have a conversation because of your network of skilled, operations.
Yeah.
Then you can sit there and go, okay, this is what you want to do. Great, fantastic. And knowing full well when you submit it to your network, it's going to say, oh, that's cool. Yeah, great. We can do that.
Exactly. And it saves them so much time between the back and forth, right? You see, lead time. And that's one of the critical things when it comes to manufacturing. It's lead time, cost, and quality, right? And that's what we bring into the table. It's like, hey, let's get on a conversation. We have our team of engineers here to help you. We can trash this out in very quick amount of time and get this manufactured for you as quickly as possible.
What's the pushback on this stuff? Because I just like, for me, maybe I'm your target audience or target a design guy, because the simple fact that I could save time, that is always like, that's great. And the other fact is that I can leverage your expertise to get the right thing at the right time, so that when you submit it, it does exactly what we're supposed to do. What's the pushback? What do you get?
That's a good question, and it varies from industry to industry, and not just varies from industry to industry, but it also varies from company to company as well. Of the three factors I just mentioned, lead time, cost, and quality, the only thing that's consistent and that's required across all board, across all company, across all industry is quality. That's all. Like, that is all that's consistent across board. When it comes to lead time and cost, depending on the company, depending on the stage of their production, depending on the project, some of them values one over the other, right? Some might say, hey, listen, we can pay you $1 million. Just get this for us by tomorrow. And some might say, hey, listen, we're not in a tight rush for lead time. We don't really care about lead time. This is a project that's scheduled for 6 months from now. So right now, we're not really concerned about the lead time. What we're concerned about is the cost. Can you bring this down? So it varies depending on what stage they are in their project and depending on the company as well. So there could be that pushback depending on what they value at the moment.
But the reality is that, you know, I speak to a lot of people, and they just want people that they can trust to have a conversation with trusted individuals, because I might not. I need to collaborate. I need to have that conversation to know that I'm doing it right, because the last thing you want is not to do it right. And it gets frustrating, and it's like, I don't want to get up out of bed because I got to deal with it. But the reality is, right? It's true. Yeah. And it would be just, I'm struggling, but at least even when somebody says I'm pushing back because the lead time is, you know, it's down the road away. So let's get it right here, whatever it is. You can still have that conversation.
Exactly. And that's what builds trust. And I believe that's what makes Fictiv stand out in the industry, is that we have roles within Fictiv that we call TAEs. That's technical applications engineers. These are the guys in Fictiv that will jump on a call with you anytime. And actually, I am one of those TAEs. We will jump on that face-to-face call on Zoom, on the phone. You could call us, email us, to have that conversation and let you know that, hey, listen, we're not just taking your part and sending it up to some random person. Like, we are heavily involved in your project just as much as you are. And we're here to make sure that your project meets your required quality requirements.
But see, you're taking a risk position too. You're going to say, hey, we want it right. We're going to work through this, and we'll also work in conjunction with you and make sure that it's right, because we want it to be right.
Correct. Exactly.
The last thing you want is to say, hey, Scott got a part that didn't meet any expectations, and that's not good for anybody, right?
Correct. And that's why we have systems in place, right? We have technical customer support. We have quality documents that we actually send out to the customer, right, before they get the parts, right? So when the parts are made, we inspect this component, we send it out to them, we send them the pictures. Hey, look at it, make sure it meets your requirements. They approve of it, and then we ship it out to them. So the transparency is there, is what it is, and I think that is crucial in an industry like this.
Gosh, how do people get a hold of you there, Samson?
You could reach out to us directly on the website, www.fictiv.com. There's a chat button right at the bottom left corner, or you could just send us an email directly. I would have to spell that out because it has.
Okay, I'll have it out there. And plus, you're out on LinkedIn, and I'll have that, and I'll have all the contact information for Samson. So don't worry. Don't worry. And
I'll have to spell it out to them. The last name, I think I might have to change my last name so it's easier for people to remember. But
it's okay, Samson. I got the Samson right. It's okay. It's okay. No problem. You are absolutely spectacular.
Thank you.
Thank you very much. All right, listeners, we're going to wrap it up on the other side. Thank you very much for joining. Thank you very much for your support. We're going to have all the contact information for Samson out there on Industrial Talk. You need to reach out to him, and you need to reach out to Fictiv, because they're pretty cool people. So thank you very much. We will be right back.
You're listening to the Industrial Talk Podcast Network.
As always, thank you very much for joining Industrial Talk, and thank you for your continued support. How about that conversation? Samson is the guy that you need to put on your bucket list to connect with. Fictiv is the company. Go out to Fictiv.com. That is Fictiv.com. And I want you to get a 10% discount. You want a quote, you want a 10% discount, you need to go right there. Test drive them. You will not be disappointed. Talk about a lot of passion at Fictiv to help solve your problems. All right, be bold, be brave, dare greatly. Hang out with Samson, and you're going to change the world. Thank you very much for joining, and we're going to have another great conversation shortly, so stay tuned.